What's up, Sim Science faithful? So I got some bad news and some kind of good news to go with it because of it. So I can't find the second to last study guide. I don't know what happened. I emailed them all to myself, but I cannot find it, so I can't put it on the screen here and answer the questions. But in a way, that's good news because that means for you guys, I'm now looking at the midterm and I'm going to go through and make sure I'm giving you all the info that you should need to be able to answer questions on the midterm. Okay, so let's start off with this equation because I don't think I put one of these on the study guide because I was told that it wasn't getting tested on the midterm, but now I'm looking at the midterm and there's one question that you're going to need to use this equation for. So if you recall, this is the speed of light. Speed of light, which is always 3.00 times 10 to the 8th meters per second. Okay, this right here is wavelength. And this right here is frequency. Okay, so let's say that you were given frequency and you were asked to solve for wavelength. What would you do? Well, you'd have to set it up like this. So you know that you have 3.00 times 10 to the 8th meters per second because you always have that. Okay, so that's always what you start with, always a constant, equals. You don't know wavelength, that's going to be your variable. And let's say you were given a frequency of 4.00 times 10 to the 12th hertz, okay, which is the same as saying whatever per second. Okay, so you're asked to solve for wavelength. Well, all you do is divide both sides by your variable. So let me break this down even simpler, or even more simply. So if we have our equation here, just the variables themselves. Okay, and you were trying to solve for wavelength, what would you do? So you're trying to solve for this one. Well, all you have to do is divide both sides by V, or by frequency, and then you're going to end up with speed of light over frequency equals wavelength. Okay, so that's all we're going to do here, just now we have numbers. So 4.00 times 10 to the 12th per second, divide both sides by that. Okay, and seconds are going to cancel, so we're going to be left with meters. I don't have a calculator on me, so, well, let me see. So you're going to, you should just plug this into a calculator, right? During the test, if you need to, you're going to just plug this into a calculator in parentheses. So it's important to know how to plug it into a calculator, but let's see. Shorthand math is going to be 3/4 times 10, 8 minus 12. It's going to be negative fourth. 3.3 over 4, 3/4, which is 0.75. 0.75 times 10 to the negative fourth meters, but to write that properly in scientific notation, we would have to do 7.5 times 10 to the negative fifth meters. That would be our wavelength. Okay, so if you didn't see how I did that, when you're dividing exponents, you subtract them. So I did 8 minus 12, which is negative 4, and you just divide 3 divided by 4, which is going to be 3/4, which is 0.75. So in your calculator, it should give you either hopefully this, or it would give you 0.000, 1, 2, 3, 4, 4075, that. Okay, but that's the equation. If you don't remember it, freshen up on it. Remember what the speed of light is, 3.00 times 10 to the 8th meters per second. Speed of light is 3.00 times 10 to the 8th meters per second. So freshen up on that if you have to, which most of you probably do a little bit. So yeah, try to remember that equation so that you could use it on your exam. Trying to put this down in a way that doesn't bother the microphone, so hopefully I can manage to do that. Let's see. Another thing, I did put this on the study guide, the emission spectrum. So when we're talking about emission spectrum, we're talking about when we drew those like box things, and then we drew color in there, like you have violet stripe to here, and then maybe a blue stripe here, and an orange over here, and then red. So we did one for hydrogen and stuff like that. So the important thing to remember is what's causing this. So like the flame test, if you think of the flame test, we were putting energy into the electrons. So if you had a little electron here in a certain energy level, you put energy, it goes up, and then when this electron gets up here, so it becomes this, then it's going to go back down. And when it goes back down, it has to release that energy it absorbed, and it's going to release it as color. So the further it drops, the higher energy color it's going to release. So I believe one question on the study guide was, what color will an electron dropping from the highest to lowest energy level release? So that would be violet light. It would be the highest energy light because it's dropping the furthest. So it would be releasing the highest energy color. If it was just dropping one energy level, it would release red light. These lines are supposed to represent energy level. So if you remember that activity we did where one person was the electron, and they had to move a certain amount and then show a color, that's what was going on there. So emission spectra. And I believe I asked why are the sun and hydrogen, why do they have different emission spectra? And that's because hydrogen has one electron, one electron moving between certain energy levels. It can move between 3 or 4, therefore releasing certain wavelengths of light. So it's a very bare spectrum with just a few stripes on it of color, whereas the sun has every element we know of. So it has so many, like almost infinite electrons. So those are moving all over the place all the time, gaining energy, losing energy, gaining energy, losing energy. So the sun releases every color we know of because it has all the elements we know of with all those electrons moving all over the place. Whereas if you're just isolating hydrogen, that has very few electrons, relatively speaking, in hydrogen gas, because each atom only has one electron. So they're going to be moving around differently. So that's why spectra of one atom versus the spectra of the sun are going to be different. And that's something to know for the test as well. In a previous video, I talked about the difference between wavelength and frequency. This is your wavelength. How often a wave occurs is frequency. So a wave like this would have a much higher frequency and much shorter wavelength. Things like that. That's how frequency and wavelength are related. As frequency increases, wavelength decreases, or I should say frequency increases, wavelength decreases. Short wavelength means high frequency. Lower energy has longer wavelength, so a high energy color would have a really short wavelength because energy is with frequency. So if you're talking about violet light, it's gonna have more energy, higher frequency, and a shorter wavelength. If you're talking about red light, I keep touching the screen. So this would be, let's say, relatively speaking, that's violet. Then red would be more like this, lower energy, so longer wavelength. Okay, so the longest wavelength color would be red, the shortest wavelength color would be violet. Let me see, I'm looking through the questions. Niels Bohr, asking about Bohr's model of the atom, where he said certain things were. Calculating subatomic particles, make sure that if I give you the 3 subatomic particles in the atom, you could tell me the atomic number, the atomic mass, stuff like that. Rutherford's experiment, what did he discover about the nucleus? This stuff I talked about in another video. Know subatomic particles, where they are, the differences between them. Protons in an atom. If it has a certain number of protons, what does it have otherwise? Like, what are the other things equal to? Models, what we use models for in science. Thomson's explanation of the atom. Significant figures. Okay, I know this is one. I think I went over this in every class, but let's do it again real quick. So a number like this with trailing zeros. Trailing zeros are only significant if there is a decimal. So this number would only have one significant figure. Just the two. These zeros are not significant. Now, if I wrote this again and I wrote 2000.0, now all of a sudden, this decimal point is showing that I'm being very precise. So then I have 1, 2, 3, 4, 5 significant figures here. So the decimal point changes everything. Captive zeros, if it was 2001, then these would be significant. So I'd have 4 significant figures. Leading zeros, if I had 0, 2, 1, these are not significant, so it would just be 2 significant figures. Leading zeros are never significant. Trailing zeros are only significant if there's a decimal. And then captive sandwich zeros are significant. I think that's the most, and then whole numbers are always significant. But if I gave you a number like 0.003401200, what would be significant here? Let's start up here. These 3 zeros are leading, so they're not significant. This is a whole number significant. Whole number significant. Captive zero, significant because it's between whole numbers. Whole number significant, whole number significant. Okay, now these 3 down here is where I think some of you might get tripped up, but we still have a decimal point, so they are significant. So here I would have 1, 2, 3, 4, 5, 6, 7, 8 significant figures. Okay? SI units, the SI unit for mass would be grams. For volume, it would be liters. For length, it would be meters. And stuff like that. Actually, for mass, it's kilograms. Yeah, that's on the poster in the room. Volume is not on the poster in the room, though. So make sure you know volume is liters, volume is liters, volume is liters, volume is liters, volume is liters. Turn up the volume, and they're like, take me to your liter. What? What did he just say? I don't even know. Like imagine you're watching a movie and these aliens come in, you're like, oh my gosh, we have to turn up the volume. This is getting intense. What's the volume? And then he's like, take me to your liter. And you're like, volume, liter, volume, liter. That was weird, huh? So something, accuracy and precision. Accuracy is how close you are to the target. Target, precision, how close the measurements are. Measurements are, sorry, I'm at a really funky writing angle right now. So if I gave you a set of numbers and asked you what's the most precise, or let's just say what am I trying to say? So if I had a set of numbers and one was 1, 2, 3, one was 2.0, 3.0, 4.0, and then another one was 1, 1.5, and 2. And I said, what is the most precise of these 3 number sets? You might be tempted to think, is this one, because this has more significant figures. But that's going to make it more accurate. The most precise is this one right here, because you have numbers that are closest together. They're only differing by a half. Then when you talk about accuracy, you're talking about how close it is to what it's supposed to be. So these 3 we're saying were all measured. These are different things being measured. If I asked you what was the most accurate and precise, and I told you how much something was supposed to weigh, you should look at what's closest together and closest to that target weight. But if we're just talking about precision, it's how close they are to each other. So accuracy and precision. Make sure you review those, and this is the type of question, make sure you know you could answer that. Physical and chemical properties. So like boiling water is a physical change because it's still water, but you're changing the state of it. A chemical change would be to change the material itself. The equation for density, so density equals mass over volume, or density times volume equals mass. Make sure you know how to manipulate that equation so that if you were given one of or two of the variables, you would be able to solve for the other one. And that's just algebra. So if I gave you density, or if I gave you volume and mass, then you should be able to plug in. If I said the mass was 6.0 grams and the volume was 3.2 liters, then you should be able to solve for density just by plugging that in. So someone said that Mr. Leslie taught you guys that a lot, so review your notes on that. This is how you set up the equation. That is on the district packet, I believe. Yeah, it is. So you'll be able to see the equation. You just have to be able to manipulate it. Filtration is separating solid from a liquid using particle size and gravity. Condensation is when a liquid condensates on something. Distillation is boiling something. Make sure you review those. I remember you had taken a quiz on that when the first day I was there. Properties. Pure substance and mixture. Pure substance is just one thing. A mixture is multiple things mixed together. An inference is something you observe or assume. Peer review is important because it allows whatever you're researching to be critiqued. You can get questions, you can get advice, things like that. Science, we're always talking about peer-reviewed journals. You always want everything to be reviewed. Scientific method, review that. Independent variable. So the independent variable is what is manipulated in a study. So it's independent of, it's not like rigidly set in place. It's not something that's always staying the same. It's independent of that. So the independent variable can be changed. So if you are doing a study on how well different age groups do on a test, and you have some high schoolers and you have some college students and some adults and some elderly people, your independent variable there would be the age, because that's what you're changing. You have different groups of people, you're changing the age of your participants. That's what you are changing in the study. The dependent variable is the outcome. Okay, so this is the scores on the tests from the study I just talked about would be the dependent variable. So if you're seeing a certain age group is scoring better, and then another, or they're getting this score and the other group's getting this score, that's the dependent variable. The score would be the dependent variable. The result you're getting is dependent on what you've been doing. It's dependent on the independent variable on what you've been changing. Or in a lot of studies it will be. Okay. Okay, so yeah, know the scientific method and what comes next. If you develop something, what do you do next, or stuff like that, scientific method. That pretty much covers everything, I think, from what I last covered on the last video onward. For those of you that want to listen, I guess I'll scroll through the test and give you some more advice just vocally right now. Periodic table, metals and nonmetals, properties of metals and nonmetals, what element would be similar to another element based on atomic number, whereas on the periodic table, the different groups of the periodic table. So if I say the alkaline earth metals, you should know where those are. If I say the halogens, you should know where those are. Know your trends, so know which way electronegativity goes, which way ionization energy goes, etc. Atomic radius, things like that. Know your trends. Properties of common elements, so those representative groups. Know their properties. Decay, make sure you know alpha decay, beta decay, gamma decay, what's released in those, what's different about them, things like that. Bonds. So for those, I think I said this to every class, but if you didn't hear it or you were in a class, maybe I didn't say it to second period, somebody already took this test, multiple students did actually, and they had issues with bonding. So make sure that the quiz is live right now. I don't know if I told 7. No, I did tell 7 period. I don't have the code on me. Actually, let me share it real quick if I can pull it up. I hope you can understand that my pencil is in my mouth. Quizzes. My quizzes. Clinical London. So it's already posted, but it just posted again. So if you go on quizzes 305741, this will give you access to the bonding quiz that you already took, so you can use that as a study guide, because a lot of the questions, or pretty much all the questions on the exam, are going to be from, or very similar to, not directly from, I don't think I did anything directly from, but they're going to be similar concepts to that. So, I mean, back to the test itself, know the difference between covalent and ionic. Know the strengths of the intermolecular forces. So London dispersion forces, dipole, and hydrogen bonding. That's in order of strength. London dispersion are the weakest, dipole's in the middle, and hydrogen bonding is the strongest. Of the intermolecular forces, none of them are as strong as a bond, but hydrogen's the strongest of the intermolecular forces. Water, know some attributes of a water molecule. Why is it polar? What's going on there? And that's we talked about a bunch of times. Oxygen's greater electronegativity is going to draw those electrons toward itself, making this a negatively charged side and making this a positively charged side. It's the electronegativity of oxygen. What kind of bonding is going on here? These are covalent bonds, polar covalent bonds to be specific. Water's ability to dissolve, it dissolves polar things because it is polar, like dissolves like. And there's hydrogen bonding between water molecules. Okay, so hydrogen bonding exists between water molecules. Okay, that pretty much gives you a general idea of what to study. Like I said in class, do your study guides, look at the study guides. I'm sorry I didn't have them in front of me, but I think that this was actually, I'm kind of worried I gave away too much in this video, so if you watched it, you're going to have a big advantage, I think. But I'll put it up anyway, I guess. So, use your study guides to guide you. Look at every section, we put a scale in our notebooks. Look at that scale and look at the learning goals. Because if you can do what the learning goals say, you are in very good shape. if you can describe blah, 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 if you can solve for blah, 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 if you can identify blah, 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 whatever those learning goals say, you're in really good shape. So use that. If you have any questions on anything, comment them below this video. I will be keeping an eye on it, and I will answer those questions. I'm not going to give you any more content or resources after this video though, because my second period class takes the exam tomorrow, and I'm not going to give my other classes more info than they had to begin with. So that does it for this. Comment your questions if you have any. Look at this quizzes to review bonding forces. Look at your notebooks. You have everything you need in your notebooks, density equation. And then, yeah, this might be something that you need to review and make sure you know this equation and make sure you know what the speed of light is, 3.00 times 10 to the 8th meters per second, and how to solve for something there. All right, any questions, let me know. Thank you guys so much for watching. If you really stuck it out, watched this whole video, you will be in good shape for your exam over the next few days.